In Learning Objective D, we're going to look at solving quadratic equations that have complex solutions. And there's 3 of them I want us to look at. We already did this one in an earlier learning objective, but I just want to show you this is considered a quadratic equation. Because there's only an x squared, we were able to just do some basic algebra. Remember, we subtracted 7 from both sides, and we came in and solved this by taking the square root. And in this case, we got plus or minus I square root of 7. So we were able to do it fairly quickly with some basic algebra, but that's not always going to be the case. Whenever you have a quadratic where there's an x squared and an x term, you can never do basic algebra and try to solve for x. In this case, it's not going to work. Now, I would always try to do basic algebra, but I realize I can't. So the next thing I might try is to see if it's factorable. Are there factors of 7, so 7 times 1, that would add to negative 2? And unfortunately, this is not factorable. So if you can't do basic square root algebra, if you can't factor it, your only other option is the quadratic formula. So let's just remember that. If you're familiar with Pop Goes the Weasel, let's write it down as we kind of sing it. Again, it's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Really great way to memorize it. So if you want to try that again, you're going to need to know this formula. So let's go ahead and identify a, b, and c. A is in front of the x squared, so a is 1. B is in front of the x, so we see that that is a negative 2. And the c is the constant, so it's 7. And let's just put this into the equation and see what we get. So I have to do negative of the negative 2 plus or minus the square root of negative 2 all squared minus 4ac. This is all over 2 times a, which is 1. Now I'm just going to do the negative 2 is positive. Negative 2 squared is 4. 7 times 1 is 7, times a negative 4 is negative 28, and it's all over 2. So this will become, inside of the radical symbol, a negative 24 over 2. Now, do not start simplifying and crossing these 2's out. You can't do it. First thing I want to do is get rid of this imaginary component that's in there, which is the negative of the square root. So let's take that out really quickly and just rewrite it. So that would be 2 plus or minus I, the square root of 24 over 2. So I've got that taken care of. Now, what I could do if I wanted to now is I could split this up into its real and imaginary component. So let's go ahead and do that. That's going to leave me with 2 over 2 plus or minus I square root of 24 over 2. Now 2 over 2 does become 1, and then it's plus or minus I. But be careful, remember from geometry, can you simplify this radical? There is a perfect square within the number 24. We could do 4 times 6. So recall, this is the same as the square root of 4 times the square root of 6. So I'm going to take the square root of 4, make that 2, put that on the outside, and square root of 6 is still there, all over 2. So the last step in simplification, our answer will be 1 plus or minus I. These 2's will cancel, and I get the square root of 6. So we just solved this quadratic equation, which has 2 answers. These 2 answers happen to be imaginary. One you could write as 1 plus I square root of 6, and 1 minus I square root of 6. Now, if you look at this equation right here, it is a quadratic. Again, I can't do basic algebra because there's an x squared and an x. And they're actually telling me there's complex conjugate solutions. Remember, complex conjugates happen in pairs. The imaginary answer just changes its sign. So we're going to have to use quadratic formula. So let's just go ahead and get this ready for the quadratic. A is 2, B is negative 12, C is 19. Remember, before we can interpret anything from here, everything must be on one side and set equal to 0, so it is ready. Let's substitute this in. X equals, I'm going to do negative of B, so I'm just going to change it right to 12, plus or minus the square root of negative 12 squared, minus 4a and c is 19, all over 2 times 2. So that's going to give us 12 plus or minus. We're going to have 144. 19 times 2 times 4. It'll be a negative 152, all divided by 4. This will then become 12 plus or minus the square root of negative 8 over 4. Now I'm going to do two things. Let's go ahead and actually break this up now, and at the same time bring the negative out and make it an I. So I'm going to do 12 divided by 4 plus or minus. Let's again make this negative, bring it on the outside, make it an I, square root of 8 over 4. Well, 12 divided by 4 is 3. The square root of 8, there is a perfect square in there. Remember the square root of 2 times the square root of 4. So I'm going to change the square root of 4 to 2. So this becomes 2 times the square root of 2 all over 4. This can be simplified further, so we'll get 3 plus or minus I square root of 2 over 2. And that's our final answer. Now the last thing I want to highlight about solving different quadratic equations is some will have integer answers, some will have real answers, and some will have complex. And you just kind of have to play with the math to see what it is. If we look at this first one and we were to solve it, x squared minus 9, by the way, you can do some great algebra on. Just add 9 to both sides and then take the square root. So what you're going to see is the answers are plus or minus 3. Well, what they did with plus or minus 3 is they just put them in their factored format. And they said, you know what? You can factor these over integers. It means you get integer nice answers. Whereas this second one, if you do x squared minus 5 and set it equal to 0, you would just add 5 to both sides and then take the square root. So x is equal to plus or minus the square root of 5. Okay, these are the solutions or the answers. We just took those and wrote them as factors here. This is not considered an integer. That's only positive and negative whole numbers. This is considered a real number. So they just said, hey, this one is factorable over the reals because I got real number answers. And then the last one they looked at is right here. So if we take x squared plus 36 equal to 0, and if you solve that, you get negative 36. Take the square root, x is equal to plus or minus. Well, the negative square root is I, square root of 36 is 6. Here we got two imaginary answers. Imaginary numbers are considered part of the complex world. So they said, hey, this guy, you can't factor and get integer answers. You can't factor and get real answers. You get imaginaries. So you can actually factor pretty much anything, but you're going to get either integers, real, or imaginary answers.